What's the concentration of a solution containing 11,7 grams of sodium chloride in 500 centimeters cubed of solution? Our question is, how many moles sodium chloride per decimeter cubed solution? In 11,7 grams sodium chloride if you have 500 centimeters cubed of solution. Now we know that 500 centimeters cubed is 0,5 decimeter cubed. So let's just quickly change that. So we have the concentration already, but its unit is grams of solute, sodium chloride solute, per decimeter cubed of solution, whereas the standard format of concentration is moles of solute per decimeter cubed of solution. So what we really need to do is to convert this grams of sodium chloride into an equivalent amount of moles. So we multiply this by a unit factor with grams of sodium chloride at the bottom and moles of sodium chloride at the top, where both top and bottom refer to a mole of sodium chloride. So a mole of sodium chloride has a mass of 23 for the sodium plus 35,5 grams for the chlorine. We do this whole calculation and our answer is 0,4 mole per decimeter cubed, which can also be written as 0,4 molar. Capital M. What's the concentration of a solution containing 2,54 grams of iodine in tetrachloromethane to give a solution of 100 centimeter cubed volume? In other words, how many moles iodine per decimeter cubed solution do we have if we have 2,54 grams iodine per 0,1 decimeter cubed solution? How did I get that 0,1 decimeter cubed? Well, 100 centimeter cubed is 0,1 decimeter cubed. How do we know that? There are 1,000 centimeters cubed in a decimeter cubed. So you always divide by 1,000 to convert centimeter cubed into decimeter cubed. So you can jump the comma back 3 spaces. So 100 centimeter cubed, 0,1 decimeter cubed. Right, so we have the concentration in grams iodine solute per decimeter cubed solution, but we need it in moles iodine solute per decimeter cubed solution. Now this tetrachloromethane mentioned here might confuse you. That is the solvent, because iodine doesn't really dissolve in water. So for our previous question, which said what's the concentration of sodium chloride solution, it just assumed that our solvent was water. It didn't name it because, well, sodium chloride dissolves in water and we often use water to make solutions. And so it didn't name it, but that was what it was implying. But now iodine doesn't dissolve very well in water. It dissolves very well in a substance called tetrachloromethane. So it's just simply named there as the solvent, and you don't need to worry about it in your calculation itself. So we need to multiply this by a unit factor with grams of iodine at the bottom and moles of iodine at the top, such that both refer to 1 mole of iodine, 1 mole of iodine molecules, that's I2. And the mass of 1 mole of iodine molecules is 2 times what we get on the periodic table for just I, because it's now I2. So it's 2 times 126,9 grams per mole. Do that calculation, the answer is 0,1 moles per decimeter cubed, or 0,1 molar of iodine solution. What's the concentration of a solution containing 62,5 grams of copper sulfate dissolved in a liter of water? Copper sulfate has water of crystallization, as you can see here in the formula. So we write down our question. We're trying to find the concentration, the unit of which is moles per decimeter cubed of a copper sulfate with water of crystallization solution, where the solution has a mass of 62,5 grams of copper sulfate dissolved in a total solution of 1 decimeter cubed. How do I know 1 decimeter cubed? Because 1 liter is 1 decimeter cubed. They are synonyms, liter and decimeter cubed. So we need to convert this concentration given here into the required unit mole per decimeter cubed rather than gram per decimeter cubed. We do that by multiplying it by a unit factor with grams copper sulfate at the bottom and moles at the top, where both refer to a mole of this. The mass of a mole of copper sulfate with water of crystallization is 63,5 for the copper plus 32,1 for the sulfur plus 4 times 16 for the oxygen plus 5 times 2 for the two H's plus 16 for the O. So 18 multiplied by 5 gives you 90. That's just for the water of crystallization. And then we have 4 times 16 for the O plus 32.1 plus 63.5. And that gives us a mass of 249,6. That is the mass in grams of 1 mole of copper sulfate with water of crystallization. Once we've got that on the calculator, don't clear your calculator. You can either put it in memory or simpler. Why don't you just invert it? Because it needs to be at the bottom of your calculation you're going to do. So how do you invert it? On this calculator, you press second function so that you get the orange things activated. And then x squared, because the orange thing above x squared is x to the minus 1. And then you multiply that by 62,5, and that gives us the answer of 0,25 moles per decimeter cubed of copper sulfate solution, which is the same as 0,25 mole dot decimeter minus 3. These are different notations meaning the same thing, which is the same thing as 0,25, in other words, a quarter molar.